In this example, we're analyzing a bicycle trip. The first part of the trip involves traveling 151.1 meters to the end of the street in 25.2 seconds. In the second part of the trip, you turn around and head home. You travel 151.1 meters back home in 27.1 seconds. The problem asks, what is your average speed and what is your average velocity over the course of the trip? Let's start by determining the average speed at which you traveled. According to equation 1.2, speed is the change in distance over the change in time. What's the change in distance? Well, you traveled 151.1 meters to get to the end of the street, and then another 151.1 meters to get back home. So the change in distance is 151.1 meters plus 151.1 meters. What's the change in time? Well, the first part of your trip took 25.2 seconds, and the second part of your trip took 27.1 seconds. So the change in time is simply 25.2 seconds plus 27.1 seconds. When you work these numbers out, you get 302.2 meters for the change in distance and 52.3 seconds for the change in time. When you divide 302.2 meters by 52.3 seconds, you get 5.78 meters per second. Let's spend a moment discussing significant figures before we move on. When we started working with this equation, we were adding numbers, 151.1 plus 151.1. In significant figures, when you add, you keep the same precision, the same decimal place, as the least precise number in the problem. Since both numbers went to the tenths place, we reported our answer, 302.2, to the tenths place. It's the same with time. Both measures of time went out to the tenths place, so we could report the sum to the tenths place as well. That's how I got 302.2 meters and 52.3 seconds. But now, to get the final answer, we have to divide. And when we divide, we count significant figures. 302.2 has 4 significant figures, 52.3 has 3, so the answer can have only 3 significant figures, and that's why the answer is 5.78 meters per second. Okay, that's the speed. But the question also asks for the velocity. So we have to figure out velocity. Now velocity is different because it's a vector quantity, so we have to worry about direction. We can define direction any way we want, but the way I will define direction is that motion to the end of the street is positive. So that means the first part of the bicycle trip involved moving in a positive direction. Now in the second part of the trip, you moved in exactly the opposite direction. So if motion to the end of the street is positive, then motion back home has to be negative. So the second part of the bicycle trip involves moving in the negative direction. Now that we've defined direction, we can figure out displacement. In the first part of the bicycle trip, you moved in a positive direction, so your displacement was positive 151.1. In the second part, you traveled in the negative direction, so your displacement was negative 151.1. So the change in displacement then is 151.1 plus negative 151.1. Now time is not a vector quantity, it's a scalar quantity. So we can just calculate the change in time the same way we did before. 25.2 seconds for the first part of the trip and 27.1 seconds for the second part of the trip. When we work out the numbers, we find that the displacement is 0. Why? Well, you ended up back where you started. So your net displacement is 0. The change in time is still 52.3 seconds, but 0 divided by anything is still 0. So your average velocity over the entire trip is 0 meters per second. What does a velocity of 0 meters per second mean? Well, that means in the end, although you did a lot of moving around, you didn't actually go anywhere. So since you didn't go anywhere, your velocity was 0. This is where the expression going nowhere fast comes from. You had a pretty fast speed, but you ended up going nowhere, so your velocity was 0.